Hello, good morning.
Good morning. Hope you are in good health. May I check with our colleagues from PSA? Miss Drix, are
Hi,
you ready already?
yes, good morning.
Good morning. Are you ready to start? Is it okay
Yes,
to start now?
yes.
Okay. I know, I think there are some participants still not joining yet, but hopefully they will joining the session soon. So thank you so much everyone for joining the session and welcome to the second day of our third session of the training. Today we still have our experts from PSA, Miss Liz, who will introduce the small area estimation implementation to us, including some exercising using the dummy data. So I think without further ado, I will pass to Miss Liz.
Okay. Hi, good morning, everyone. May I just clarify regarding the hands-on exercise? I was trying to run it in R, however, I am not yet successful.
Okay.
So maybe I can just show the packages that I was trying. And maybe some of the even the our experts here who are participating can explore it already. But since the Philippines will also be presenting for the next week on
Mhm.
our fourth topic, I think once I've successfully run the data, the codes, maybe I can demonstrate it. But the materials I've already provided the initial commands in
Sure,
running the SAE.
sure. And I think hopefully later on there will be some colleagues from BPS Indonesia who also have some expertise on using R.
Okay,
So
yes.
they might also provide some input.
Okay.
Okay.
Sige.
So
Okay,
I
thank you.
think it doesn't matter. You can just show us the packages that you already tried to run, and then let's see what we can do later on.
Okay.
Thank
So
you so much.
I will may I start? May I share
Sh-
my
Sure,
presentation?
sure, please.
So okay, I think it's already being shared. So as mentioned yesterday, there are various small area estimation techniques that can be conducted depending on our interest or our available data. So for now, I will be presenting some or specific direct and indirect estimation techniques being used to compute for small area estimates. Um, so the outline of the presentation will be on the small area estimation process. This is a short recap on the main idea of computing for small area estimation, and then a specific direct estimation technique and another specific indirect estimation technique. And then I will also be showing the SAER package that I have tried to explore to familiarize the participants um, with the available R packages on small area estimation. So as presented yesterday, there are various small area estimation techniques, namely the direct method, traditional indirect method, including demographic, synthetic methods, and composite methods, as well as model-based methods, which includes the E-Bloop, the empirical-based method, the hierarchical-based method, as well as the ELL method. So first, in identifying the small area estimation process to take, our initial objective should be to identify our end goal in estimating for the small area estimates. And then we identify the available data or the variable of interest and its form. And once we identify those data available, we now decide, depending on the presence of auxiliary data, whether we have limited to none auxiliary data or we have several good auxiliary data. So if we have limited to none auxiliary data, we consider an SAE approach using direct estimation, broad area ratio estimation, the synthetic or the calibration method, and the survey weight reallocation. Well, if we, after assessment, we determine that we have several good auxiliary data, once we identify our variable interest, we can conduct SAE approaches such as regression, synthetic estimation, empirical based linear unbiased prediction estimation or the EBLOOP. Another SAE approach is if we need the total counts, we conduct the Poisson regression estimation. And then if our approach is obtaining the proportion or ratio, we then use logistic regression estimation. So after we identify the methodology that we wish to take on, we calculate our small area estimates, and then we evaluate the small area estimates based on the criteria that we have set initially to identify if our small area estimates are reliable for at the level that we are looking into. So what are the main considerations in the small area estimation? First, we identify the use of the small area estimate. So we identify the main objective of generating lower level statistics. So what do we need it for? Who will be the one needing it? So those are the initial considerations that we should answer. And then on the topic of interest, we should also identify the indicator to be measured. This is to ensure that the auxiliary variables that we have is sufficient to measure our area of interest or topic of interest. So once we identify or assess the requirements of the indicators of our concern indicator, we then identify the level of disaggregation that we need. By identifying the level of disaggregation to generate the small area estimates, we will be able to further assess the data that we will be needing. So once we assess the topic of concern and then assess the level that we need for the data, um, we then compare it with what is available or what is the data available that we can use or that is relevant in, to the concerned topic. And then we should also try to explore other non-traditional data sources such as big data, satellite images, citizen-generated data. It will be up to the group to identify relevant indicators to help better generate reliable small area estimates. So once we will be able to answer those, once we go back to our estimation process, we will now be able to identify the approach that we should take on, given that we have checked the objective, the topic of interest, and the level of disaggregation, and the available data. So once we know those, the selection of methodology to take will be, we will have a more shorter list of methodology, of small area estimation methodology to consider. So, so further, to the general difference of the among the small area estimation is that we have small area estimates and we have indirect small area estimates. So the direct estimates are direct estimators based on data obtained from the sample units in the area of interest. That is, it is area specific. Well, it can be considered the same as design-based when estimation is done under planned domain of analysis. So for example, our direct estimate is based on survey design. So those are examples of those. While the indirect estimation is also known as a non-traditional or model-based approach. So it borrows strength from sample observations of related areas to increase the effective sample size. So indirect estimation is our response to the disadvantages of our current or our available data for our indicator of interest. So these are just other definitions that we may be able to encounter as we go on with the discussion. So this is based on the a book of Rao and Molina and Cochrane. So we define the unit of analysis as the level at which a measurement is taken. For example, persons, household, farms, or firms. So once we take on a small area estimation technique, we must first identify at what level are we trying to measure. For example, we wanted the total counts of individuals or the total counts of households. So that will be our unit of analysis. And then we also must identify our target population or universe. So the population, this is the population of interest from which the relevant information is desired. For example, the country's population in the case where national living standards are the objective. So it will be depending on the question of who will be using our data. So who will be using our data? They will be the one to answer the what is their target population. So also we define the domain or area as denoted as D, which may be defined by geographic areas such as state, county, school district, health service area, or socio-demographic groups, or both, such as specific age, sex, race group within a large geographic area, or other subpopulations such as firms belonging to a census division by industry group. So small area estimation is not limited to geographic areas. It can either be socio-demographic groups or other identified subpopulations of interests. And then we define finite population parameter as the theta, wherein the quantity computed for the big N measurements or the total population in the units of analysis in the population. It is often a descriptive measure of a population such as the mean, variance, rate, or proportion. And then the theta hat or the estimator function of the sample data that takes values close to theta. So our true value is the finite population parameter, while our estimated value is our estimator, or this is usually from sample data or from survey results. While the direct estimator or the theta hat D of the theta sub D, um, this is the estimator based only on a domain-specific sample data. For example, we have the estimator or the theta hat. This is the estimate for the total country. However, we want to generate an estimate for a certain area or for a certain city. The notation for that estimate will be the theta hat D because it is only a from a sample result to a specific area. So an estimator of an indirect for an area, so area D is the theta D is direct if it is calculated only using data from that domain or area without using data from any other area. So these estimators have advantage of being at least approximately unbiased, but tend to have low precision in areas with small sample size. So this is this is actually a translation of the disadvantage of having only direct estimates. So since they have lower precision, coming from small sample sizes, we then resort to using the indirect estimation technique. While the unbiased estimator under the sampling design is defined if the estimator's expected value, for example, mean, across all the possible samples is equal to the population parameter, if its design bias is equal to 0 for all the values of parameter. So the estimator theta hat of parameter theta is design unbiased if and only if the it is close to 0. So our objective specifically, for example, when we generate our survey, we make sure that our sample is sufficient. So this is just a measure of making sure that our results are unbiased. So this is the measure that we must make sure that the expected let's say summary statistics obtained from the survey should be close or equal to 0 by difference to the true value. So that's our objective for having reliable sample sizes when we conduct our surveys, that we want to always make sure that there is no bias and that we are actually measuring the true value of our indicator of concern. So while the estimation error, of course, statistically we cannot always generate zero, we cannot always generate unbiased estimates or zero errors. So for the estimation error, this notes that the estimation error for a given sample is typically different from zero, even if the estimator is unbiased. So based on our surveys, typically it is not zero, but the objective is to be at least close to zero. And the design bias is the mean estimation error across all possible samples. While the mean squared estimation error, or the MSE, is the bias plus the variance in the design-based setup. When I say design-based, I think this is the survey design setup where data is not random. In the model-based setup, it is MSE equals bias plus the variance of theta hat minus theta. So this is the variance of the model. And for the standard error, which denotes as SE of the theta hat, this is the standard deviation of the sampling distribution of the estimator theta hat for the parameter theta. So while the coefficient of variation is also our measure of this is our measure of precision. I'm sorry. Standard error is the measure of precision, and then the coefficient of variation is our measure of reliability. Wherein the CV is just the square root of the variance over the our estimator, which is, for example, we have the poverty incidence. The square root of variance is just the standard error of our poverty incidence, while the denominator is our poverty incidence. So this is the associated standard error of the estimate over the expected value of the estimate. So when the estimator, the it is when the estimator is unbiased, yeah, the expected value of the estimate is equal to the data or the true value when the estimator is unbiased. So the CV is also known as the relative standard deviation. So further, so this is just to familiarize on the terminologies or the concepts that we may encounter as we go along discussing the other small area estimation techniques. So to discuss the direct estimation, indirect estimation, there are common parameters such as population total, population mean, and population ratio of total. So these are the notations wherein the population total is the summation of all the observations, while the population mean is the summation of all the observations over the total population, or yes, and then the population ratio is the um total to the um uh interest, or the x of your interest topic. And so these are just the notations that we may encounter as we go along. So y is our characteristic of interest, or for example, we want to estimate a certain variable, so that will be our y. For example, for poverty estimation, we usually predict the poverty incidence. So most of the time, either our Y can be poverty incidence, per capita income, per capita consumption, or unemployment rate, underemployment rate, whatever is our variable of interest. While the X's for most of the model-based approaches, or the regression methods, we refer to the X as the vector of auxiliary variables, while we refer to the Y as the population total and N as the population size. Y sub I is the ith area total, um, and Y bar sub I is the ith area mean, while P sub I is the ith area proportion, wherein Y is either 1 or 0, since for example, Y is either you are poor or non-poor, for example. And then S is the overall sample, while N is the sample size. So under the design approach, the estimate this might just be um, this is just an illustration of how we generate for the direct estimate, but this is just a more statistical approach in illustrating how we generate, for example, for the poverty incidence or for the proportion of poor. So, for example, let's visualize that we are generating for the proportion of poor. So the estimator of the population total, denoted by y hat, is said to be designed unbiased. So if this is just an illustration of that we are estimating for the um, proportion of poor, wherein y is the actual proportion of poor in respect to the total population. So we are this is the design variance based on the survey that uh, based on the survey design of the data source of estimating for the proportion of poor. So y is the proportion of poor. And then, of course, we have to check for the measures of precision, reliability, and accuracy. We also obtain the design-based mean square error, wherein this varies depending on the survey design. So, for example, if you have stratified samplings, simple random sampling, or whatever the survey design is. And the estimator y hat is design consistent if y hat is unbiased. And the variance for y hat is close to 0 as the sample size increases. So as long as we make sure that our survey, or the survey that we conduct, follows the criteria in generating reliable estimates, we can proceed with the estimation of the direct estimates with um our making it unbiased, and the variance is close to 0. So this is how we estimate the total population. So given the design weights or base weights denoted as y sub case, the design unbiased estimator of y is just the summation of the y as the indicator, let's say poor or non-poor, and weight is the assigned weight based on the survey design. So, for example, when we are estimating for the number of poor, or for the poor population, we as we design our survey, we have a specific weight for the sample household. So we will just multiply the weight for that specific sampled household to our indicator, which is either they are poor or non-poor, and then we get the summation, and then the y hat, then that will become the y hat, or the sum of the weighted poor based on our survey, based on the survey design that we have conducted. So y sub k is the inverse of the first order inclusion of probability of the lambda sub k, wherein the probability that a unit of the universe is included in a sample based on the sampling design. So this is the y sub k is just the common weights, or the usual weights being used by order. We refer it for our family income and expenditure survey. We refer to our weights as the raising factor, since the surveyed household will be raised, or will be representing a certain group of um, population. So we call it the raising factor when we refer to our survey weights. And then for the estimation of the population total, or for our discussion, the poverty, um, the y sub k, as I mentioned, y sub k, or the weight, or the raising factor, may be interpreted as the number of units in the population represented by that certain sample unit. So once you identify your unit of analysis, for example, your unit of analysis is at the household level, the W sub k represents the number of units in the population being represented by that unit of analysis that you have collected your survey data. So often, the sum of the total weights, or the total W sub k, provides an unbiased estimate of N, or the total population, or whatever population of interest you are referring to. For our case, since the Family Income and Expenditure Survey is made to represent the Philippines at the national level, so when we get the sum of our weights, we get the total number of households in the Philippines for that specific reference period when the survey is conducted, wherein the basis of our N is the population projection for the years that the census is not being conducted. And then for the values of the lambda sub case, um, there are um, what you call this? There are certain change, or certain variations depending on the survey design of the data that you are obtaining it. So for example, for the in one stage sample random sampling, lambda sub k is just the sample size over the total population, while in stratified random sampling, you have a different it depends on your stratification. And then the two-stage sampling, or the SRS in both stage with an equal sized primary sampling units, we consider the first the two stages of the sampling. That's why we have the A over small a over big A times the B over big B. So it depends on the survey design. And then for the specifically for the two-stage random sampling, or at the first stage, the primary sampling at the first stage, and the SRS in the second stage, is per, mm, the lambda sub k is A times B over summation of B, and multiplied by small b over big B is equal to AB over N. So this denotes the total number of PSUs. Refers to A refers to the number of sampled primary sampling units, while B referred to the number of sampled secondary sampling units in the primary sampling units, while big B is the total number of secondary sampling units in the primary sampling units or the PSU. So this is just an illustration on how we assign the weights depending on the survey design. So once we have, in actual practice, the expansion of the estimator is of the form y hat is equal to y sub k w sub k multiplied by y sub k, where w sub k star is just w sub k multiplied by d sub k, wherein d sub k is an adjustment factor employed to take into account for the non-response unit and coverage, such as post-stratification, to ensure that the totals would conform to some known totals or the population projection. So this is a case for the Philippines because the prediction for the population does not necessarily align with the projection on the total number of households. So we have to adjust our weight for, because for the family income and expenditure survey, the unit of analysis is at the family or household level. However, our population projection is at individual level. So we cannot directly just divide the average family size to the population to obtain the number of households, because um, we have to take note that there are variations in the number of family size per housing unit. That's why we cannot directly capture it, the number of households for that certain year wherein the population count is based on a population projection only. So in estimating for the ith area total, the direct estimator is referred to as y hat sub I. Noting that the y hat sub I ensures additivity. It means we can add the per domain results, and we will still get the national or the country level results. That is that the summation of the y hat sub I is equal to the y hat, and that the y hat sub I cannot be used if the sample is empty or the sample size is empty. For and that is how we conduct the direct estimation for the Philippines, for the case of the poverty statistics in the Philippines. So later on, I will be showing the how you can just easily get it using the R command, because there are packages available, or you can directly, for us, we usually use data in generating poverty statistics. So that is the official poverty statistics is a direct estimation of our official of our poverty results. Well, on the model-based estimation, or actually, I've mentioned earlier that there are other indirect estimation, but I will be zeroing on the e-bloop or the model-based estimation, since the topic for the next session is on the e-bloop, or the empirical based linear unbiased predictor estimation. So going to the model-based estimation as one of the indirect estimation in small area techniques. For the Philippines, we are also using a model-based approach. However, the difference between maybe I will just get that on a later part. So regarding the model-based approach, recently model-based methods of small area estimation had received attention because of the following advantages. So model-based methods make specific allowance for local variation through complex error structures in the models that link the small areas. Also, efficient indirect estimators can be obtained under the assumed model. So not only we can generate for areas that are not part of the survey or not did not have samples, we can even generate them to be reliable at the small area level. Also, models can be validated from the sample data, and methods can handle complex cases such as cross-sectional and time series data, stable area specific measures of variability associated with the estimates can be obtained, and unlike the overall measures for synthetic and composite estimators. So based on our case for the Philippines, model-based approach is a much more convenient way for us because aside from we have the flexibility to identify the um, to provide poverty incidences at areas that do not have income data. We can also add other auxiliary variables that are not part of the survey or the census. For example, including nighttime lights in your models or including other administrative data or other citizen-generated data that may have relevant impact to the model that you are creating. Further, when we do the model-based approach, we have the direct estimate. We have two components. We have the direct estimator, which is equal to the sum of the parameter and the sampling error, which was the part of the direct estimation, where the sampling errors are assumed to be independent across areas denoted as I, which means with mean zero and known variances of phi sub I. In practice, sampling variances phi sub I are seldom known, but smoothing of direct estimated variance is often done to get stable estimates, which are then treated as the true phi sub I. And the other part or the secondary component of the model-based approach is a linking model that relates to the theta sub i's to area level auxiliary variables z sub I through a linear regression model where the model errors are assumed to be independent across areas with mean zero and common variance and independent of the errors, and the beta is the p-vector regression parameters. So this is an illustration of the model-based approach, or this is the model that we are referring when um, generating for the small area estimates. Combining the two components, we get a combined model. So the theta hat sub I is equal to the c sub I, wherein these are the C sub I are the auxiliary variables, the values of our auxiliary variables, while the beta is the coefficient of our auxiliary variables. So which is the form of a linear mixed effects model with fixed effects beta, or the coefficient, in random small area effects, or the error, and the parameter um, rho sub squared is a measure of homogeneity of the areas after accounting for the covariates of z sub I. So, however, since I mentioned that there are already many available packages in Stata, in R, that you can just adapt without going through the nitty-gritty of computing using the actual coefficients of the model. It will be easily generated using the packages that are available for R and Stata. So specifically on the eBloop approach, or the empirical-based linear unbiased predictor method, is applicable for linear mixed models. So the eBloop estimators do not require distributional assumptions on random errors of E sub I and V sub I, but normality is often assumed for MSE estimation, or the mean square error. So for the linear estimator, with fixed coefficients is called a linear unbiased prediction, or the LUP estimator of the realized values of the theta I if the expectation of the deviation with respect to the combined model is zero. So as same with previous assumptions that our estimators should have error still close to zero, making sure that the estimates that we are generating are actually relevant and reliable. And then this is the initial estimator presented during in 1990 by Prasad and Rao. They gave the following best linear unbiased predictor estimator of the realized theta sub I under the linear mix model. So I will just skip this. This may be too technical for the current discussion. As well as the in this estimator, the second component is the indirect. They are also just illustrating that the theta sub hat uh, or the predicted values from the best predicting model obtained through weighted least square provides another set of estimates, which is commonly referred to as the regression synthetic estimate. So once the assumed normality of the random errors are confirmed, then the marginal distribution of the theta hat sub I is normal with mean C sub I, with the mean and the variance is and the theta sub i's are independent. So using the result, the restricted maximum likelihood estimation, or the REML of beta and the sigma square V can be obtained. So the REML estimators for linear mixed models remain asymptotically valid under deviations from normality. Therefore, the E-bloop estimator using the REML estimator of the sigma squared sub V is also asymptotically valid for large M under not under deviations from um, non-normality. So we are just explaining that um, as long as we have a large sample, we can assume normality. Further, on the application of the E-bloop method, um, we will be referring to the poverty incidence as our y hat sub I, while our z sub I is the vector of auxiliary variables, or this is just the list of the variables that we have identified that we want to be included in our regression model. So for example, c sub I can be the number of household members. C sub I can be the presence of a household member who is participating in an agricultural sector. And the beta sub I is the vector of regression coefficients, while the V sub I is the model error and E sub I is the sampling error, wherein I is our area, or the level of disaggregation that we would like to generate small area estimates to. So based on the results, we make sure that the predictors in the best model should be proportion of the total population. This is just a usual based on previous study. We make sure that the predictors are aligned. For example, since we are measuring for poverty, we include auxiliary variables that have significant effect to the poverty incidence. For example, portion of population excuse me, proportion of population who are headed by a male married person who had reached at most secondary education, since based on previous studies, we know that education is highly correlated to poverty incidence, or highly correlated to income data. So, for example, and then dependency ratio, wherein we consider also the household members who are dependent to the income generating members. For the area level auxiliary variables, we also include population density, Well, we also the average household size and whether the um, dependent children are enrolled in private schools for secondary education. Those are also good measures to include or good auxiliary variables to include in our model. So just to differentiate the e-bloop method, you can use area level variables. Well, for the ELL method, um, you can use area and unit level auxiliary variables. So maybe in the next session we can also differentiate the the data requirements when generating small area using the eBloop and generating small area estimates using the ELL methodology. So based on our this is just a illustration on how we go about with estimating for the eBloop method. So based on the auxiliary variables that we have included in the model, so we should check for the sign of the coefficient or the beta. So we must remember that our y or our variable of interest is the poverty incidence. So by checking that the by the auxiliary variable of the proportion of provincial population whose household debt is married male and has reached at most secondary education. So this means that the household head did not reach tertiary education or did not get any bachelor degrees. So that variable has a positive effect on poverty incidence. So it means that as the proportion of population with household heads having only an education attainment at the secondary level, it is contributing to the poverty incidence, as well as the dependency ratio, wherein the higher the dependency ratio of a certain domain or population group means that they are contributing more to the poverty incidence, because the lesser the dependency ratio means that there are more income generating members rather than dependents. So for the poverty incidence to be lowered, we want more household members to be self-sufficient or to be working to be able to lessen the poverty threshold. Also, the population density is also has a positive effect on the poverty incidence, and the number of household members also has a positive effect on poverty incidence. So, the higher the number of family members or the higher the family size, it has a positive effect or contributing to the increasing of the poverty incidence. While enrollment in private schools of a province for secondary education has a negative effect, since when a household only enrolls their children to private schools, it means they can afford an exclusive or a more expensive education for their children. So it means that they have a higher income, so they are less likely to be contributing to the poverty incidence of a certain domain. So those are the um, one of the criteria that we must also check when generating regression models, that I believe some of us may already have been familiar with this concept. And then with the design-based and model-based estimate, so the empirical best linear unbiased estimator is given by um, y sub I is equal to the lambda sub y hat sub I plus the um, 1 minus lambda sub I, wherein the c sub I, this is the auxiliary variables with the coefficients, where the lambda sub I is just the um, theta sub theta square over theta square plus theta hat square of the error and the variance. So this is just the um, where the lambda sub I is just the error, or the weight for the e-bloop. Since the e-bloop has two components, so we mix the component from the direct estimation and the component from the regression model. So it's like a weighted mean. And then the results showed that this is just the distribution of the poverty incidences from um, each of the domain generated. So further, we can compare that the e-bloop as the difference in the results of the design-based and the e-bloop on the poverty incidences generated. And these are just this is the area level results. So this is just a snapshot on the certain provinces that have generated small area estimates. So as you can see, once we generate the Y, our poverty incidence, we can also generate our standard error. And from the standard error of the estimate, we can generate the confidence intervals as well as the coefficients of variation. So this can be our end result when generating the small area estimates of poverty. And further, we also check the reliability of our e-bloop results. So as mentioned yesterday, um, our usual cutoff is at 10%. Once the coefficients of variation exceeds 10%, we usually have a cautionary statement or a caveat that estimates with coefficient of variations greater than 10% should be used with caution and may not be that reliable compared to the estimates with coefficient of variation less than 10%. So this is the comparison of the coefficients of variation. As you can see, the e-bloop results yield better CVs or coefficients of variations compared to the design-based estimates. And this is just the distribution of the errors. So as much as possible, we want them to be close to each other or equal to 0. The difference should be close to 0 to make sure that our um, indirect estimate should not differ largely from the design-based estimates, since the design-based is obtained from actual samples collected from the survey. So for the, I will also be, so this is the end of my presentation, but I will also be showing the statistical package that I have tried to explore in generating small area estimates using R. So hopefully, since as mentioned by Ms. Warda, I know that there are experts on R who are part of this capacity building. So maybe they can already start exploring um, the SAE techniques available in R. So this is the R package being co-authored by Ms. Isabel Molina, an expert in small area estimation. She is also one of the consultants of many other institutions or organizations in estimating small area estimates. So she has been big part of the recent development in the ELL methodology being used by World Bank, and now it's called the EB census methodology, wherein this is only an improvement from the previously ELL methodology. Now they are referring to it as the census EB, available in the data package of the um, available in the data package of SAE developed by World Bank. So Miss Isabel Molina and her colleague Miss Yolanda Marwenda. So this package is recently updated. There was an initial update with the Fay Harriet model in 2015, but now this includes all the other SAE techniques that have been explored by the statistical community on small area estimation. So the SAE package includes for the the SAE package, or the small area estimation package in R, provides a variety of function for small area estimation, including functions for mean squared error estimation, basic estimator including direct estimation, post-stratified synthetic estimation, sample size dependent, and for the model-based approach, this R package includes eBloop based on the Fay-Harriot model and eBloop based on a unit level nested error model and estimators obtained from spatial and spatiotemporal Fay-Harriot models, and the empirical based method on the unit level nested error model for estimation of general nonlinear parameters are also included in the package. So this package provides functions for estimations in domains with small sample size in in car um in relation to the main objective of generating small area estimates. So this package is also available is already available in R. So you can just install the package once you explore it in your R program. So there are also references on the studies that have been conducted based on the methods included in this package. So one of the initial inclusion is the Box-Cox transformation and its inverse, because usually the predictor is Y. Uh, the predictor Y is usually income or the expenditure, and we know that they should be transformed to be able to generate a better model for estimating this indicator. So they also have a Box-Cox transformation included in the package for more convenient way of estimating. And then the description is already available in the usage. And for the to go further, I believe the data are also included. However, I was trying to use the data from the Philippines, so maybe that's why I was not able to run it correctly. Also, given that I am also not that familiar with R, but I will try to for the next session I will try to um incorporate maybe their own data so I can proceed with the um, demonstration of how to generate the direct and the eBloop estimates using this R package. So for the direct estimate, as you've seen in my presentation, it may seem complicated, but the direct estimation is pretty straightforward in this R package. So this just calculates the direct estimators of the domain mean. So just have to identify your Y or your variable of interest, your domain codes, and then your survey weight are the domain size or the sample size, and then your data for your data frame, and then the logical variable with default value for the random sampling without replacement, and true for random sampling with replacement if that's your survey design. So there are also definitions on the values being used. So for example, the domain codes should be in ascending order, domain sample sizes, and the direct estimator of domain means of variable Y. So I believe this documentation of the SAER package is already pretty comprehensive, um, which may be easily replicated by those that are very familiar already with R. So we also generate the standard deviations. So the estimation or the formula for the standard deviation may no longer be an issue because it can be generated for even for the sampling design. Aside from SRS, Poisson sampling also is considered, and the CV is also generated, and there are already examples on how to compute for the direct estimation. So for the direct estimator of the, for example, the example is that they are estimating for the mean income for each domain or province. So once you have your income data, you can use the R code or R command for the direct estimation. So you can just fill in the necessary parameters to come up with the results. And you can even tweak them upon your convenience. So as mentioned, the empirical based methodology is the eBloop is also available in this R package, and she has several EB estimators such as an indicator with non-sample values of auxiliary variables. So this fits the REML mentioned in the presentation, the unit level model to a transformation to of a specified dependent variable by a Box-Cox family or power family, and obtains Monte Carlo approximation of EB estimators. Since you will be uh, the simulation of the results is already included in the R package, so you can just identify the number of simulations you would prefer when you run the um, eBloop or the any other available model-based approach in this package. So this is the EBHF or the empirical based Batis, Harter, and Fuller, while the other includes the, apologies for going over this quickly. While the eBlow approach is also available, which is the um, eBloop of domain means based on the nested error linear regression model. So this is based on the this function calculates for selected domains of eBloop domains of means based on the nested error linear regression model of the BHF approach. So with the same parameters available, you can just identify the variables in your data that you can include in the R command. So, so the details is that a typical model has the form response terms where response is numeric, which specifies a linear predictor for response, and the term specification of the form first and second indicates all terms in the first together with all the terms in the second with duplicates removed. So for further detail on the methodology, it is also available. The references are also available. So for once you identify the methodology that you want to explore, you can just refer to the notes and the details specified in this package. So the examples basically just shows us how to load the data, and then automatically the loading and the defining of the variables, and then we can run the specific command, and then after running the command we can now call for the results of the eBloop regression methodology. Further, it is also available using the eBloop based on the Fay-Harriot model aside from the BHF model. So this function gives the eBloop or the EB predictor under normality based on the Fay-Harriot model, and wherein fitting method can be chosen between ML, REML, and the FH methods. So the arguments are also included with the details and the values necessary. Also, the if you are if you want to include the spatial variables, you can also use the eBloop SFH. So it is also available in the package. And then you can also, the spatiotemporal is also available in the package. So further, the examples are already available, and you can also further the following pages are already on the available data that they have used in the example. So you can refer to the available data sets, and the other measurements of accuracy, reliability, and precision are also available. Or also, they have also defined the other measures being generated for the package. So that will be all for the um, for my presentation for today. So hopefully, you were all able to grasp some of the concepts. Although, um, I'm so apologetic that I was not able to provide you the necessary exercises. However, I will try my best to learn R and be able to share them with you next week. Thank you.
Thank you so much, Ms. Lid, for walking us through on the direct and indirect estimation on small area estimation. I would like to invite all participants if you have any question or comment. Or maybe if you have extensive experiences on using R and you have any input also to Miss Grace on her problems, you may also provide your input. May I check whether we have our colleagues from BPS Indonesia? I see Miss Diar and Miss Reni. Maybe you have some experiences using R for the direct and indirect, and you have some suggestion for Miss Rich on her problems. Or any other participants, if you have any question. Hopefully, yes. Hello? Someone is talking. Check who's talking, who speak before. Hello? But, but dear, are you trying to say something? I think problems with the microphone. From Myanmar, do you have any question?
No, we have no question.
Thank you. So looks like everyone is already understand about the presentation. So far I don't see any hand raise or and no question in the chat box also. Sure, we'll share the slides later on. I check from participant from other country, please. From Laos, do you have any question or any issues that you would like to ask, not only to the current presentation, but if you have any question which related to the previous ones, you it's also welcome. Since no question, so thank you so much, Miss Rich. But before we end our session today, I think as I mentioned yesterday, we will have some short sharing from Miss Dia from BPS-Statistics Indonesia regarding the selection of variables. So thank you to Miss Dia, ASEANstats short notice requesting Miss Dia to give some brief explanation on how to prepare the data and how to select the variables that will be used for the hand-on exercise later on in the last training I think in early December in the last training of our series. So without further ado, I will pass to Miss Diar, please.
Thank you so much. I'm sorry if there was a bad connection here, but hopefully from now on until later the connection is already stable here. Yes, good morning everyone. Thank you. First, I would like to thank our college from PSA of the materials this morning. And as mentioned by Bu Wardah, Miss Wardah, we will try to, because ASEANstats request that some of you may have a little bit confusion what we need to do for this pilot study. So here I want to present and I want to share to you about the data preparation before we do the pilot exercise for small area estimation, please. Yeah, please proceed to the next slide, please. Yeah, this is some background. I wish after this session we have some understanding about data preparation and about small area estimation. I assume that all of you here by now have already understand what small area estimation means, because our college from Philippines has explained very detailed about small area estimation for these 2 days. So here I just want to give the real example of small area estimation preparation in the case of Indonesia. So after this, I hope you can try to imagine what kind of data that you need for small area estimation and what data is available in your country and what you should do with the data so that you can use that data for small area estimation. So here, in the case of Indonesia, poverty rate and unemployment rate are generated from specific survey. For instance, in Indonesia, the official statistics of poverty rates is at the municipality level. So the official statistic of poverty rate is at the municipality level, and this indicator is generated from National Socioeconomic Survey, or we call SUSENAS. On the other side, the official statistics of unemployment rate is also at the municipality level and is generated from labor force survey, or we call SAKRNAS. So I hope you can start to identify by now what survey in your country that is used to generate those two indicators, and what at what level those two indicators are officially published in your country. So let's try to identify, in my country, to generate poverty rates, we use what kind of survey? To generate unemployment rate, we use this survey. Okay, we publish it officially at let's say province level or municipality level. You can identify it by now. After that, let's back to Indonesia case. We have the official statistics of poverty and unemployment rates at the municipality level, like what I said before. However, we want to estimate the poverty level and the unemployment rates at the more granular level, let's say at sub-district level. So we want to estimate the poverty rates and unemployment rates at the more granular level, let's say sub-district level, because we want to know where the specific area or sub-district in a particular municipality that have high poverty rate or high and unemployment rate in order to make a proper policy. So we need to know exactly where sub-district that have high poverty or high unemployment rate. So how to get the accurate estimate for the small areas such as the sub-district level or village level? Because our survey is not designed to generate the estimation at those level. Our survey, in the case of Indonesia, our survey is designed to generate estimation at the municipality level. So we cannot generate the estimate for sub-district level because it's not reliable enough. We don't have enough sample for that. So how to get the accurate estimate for the sub-district level? Therefore, there is small area estimation. So small area estimation is one of the solution. Can we proceed to the next slide, please? I hope you can get the background of this study. So in order to do small area estimation, the first thing that we need to do is basically these two things. The first one, we need to prepare the direct estimate of the targeted variables, which is poverty or unemployment rate. You can choose which one is your concern. You can choose poverty rates or unemployment rate. And then you should prepare it at the small area that become your concern. I mean, like, as I mentioned before, in Indonesia, we don't have a good estimates for sub-district. So my concern is to do small area estimation in sub-district. So you must prepare the direct estimate of poverty or unemployment rate in the level that become your concern in the study. For example, village or sub-district. And then the second thing that we need to do is prepare the auxiliary variables in order to predict the targeted variable. In this case is poverty or unemployment rate. Next slide, please. Okay, let's dig deeper into the first step, which is prepare the direct estimate of the targeted variables. So I assume that by now you have already identified the survey data in your country that is used to generate these two indicators, poverty and unemployment rates. Like what I've said before, in Indonesia we use Susenas to generate poverty and Sakernas to generate unemployment rate at municipality level officially. I also assume that by now you have identified which division in your institution or in your country that produce those kind of survey. For instance, in BPS Indonesia, we have Directorate of Demographic Statistics that conduct Susana survey, and they also produce the official statistic for poverty rates in municipality level. We also have a Directorate of Labor Force Statistics that conduct Sakernas data, Sakernas survey, and they also produce the official statistics for unemployment rate at municipalities level. However, like what I mentioned before, for the small area estimation study, we need the estimation at the more granular level, let's say sub-district level. Therefore, the thing that you need to do is, it is the simplest way. Ask those department, for instance, in my country, ask Department of Demographic Statistics, Directorate of Demographic Statistics, or Directorate of Labor Force Statistics, ask them to provide you with direct estimate of poverty or unemployment rate from their survey at the small area level that become your concern for the study. And you also need to ask them the RSE, relative standard error of the direct estimate of the poverty or unemployment rate at the small area level. So please pay attention for the last sentence in this slide. So you need to ask the department that is in charge for the data to provide you with the direct estimate and relative standard error of the estimate at small level. If you are, okay, we have learned in this session how to produce direct estimate and indirect estimate. If you are confident enough to generate the direct estimate by yourself, you can do it. But however, if you are not sure and not familiar with the survey design of the survey design, please just ask the department or the division that is in charge of that survey, because some of us, including me, I also don't really understand the sampling design and the weight of the survey, so I'm not confident enough to generate the direct estimate by myself. So I just ask them to provide me with the direct estimate and also RSE, because they that division is already familiar with the data, already familiar with the survey, because they conduct the survey and they produce the indicator, so they familiar with the weight and etc. So I suggest, if you are not confident enough or you are not familiar with the survey design, you don't need to generate the direct estimate or RSE by yourself. You can just ask them to provide you with the direct estimate and RSE at the level that you are concerned, that become your concern in this study. So you can get the direct estimate and RSE at the level that you concern. Maybe we can move to the next slide as an example. Yeah. So it is the example for Indonesia case. We officially publish unemployment rate at municipalities level. However, we want to estimate unemployment rate at sub-district level, but we don't know how. I mean, like we don't have the direct estimate and also RSE. So what we did, we just asked the Directorate of Labor Force Statistics to provide us with the direct estimates of unemployment rate at the sub-district level, along with its RSE from the survey. So as at this slide, you can see, this one is poverty level. You can see the poverty rates at the sub-district level, the direct estimate of poverty rates in the sub-district level, and also the RSE. So just as in Indonesia case, we just ask the Directorate of Labor Force Statistics to provide us with the direct estimate for the poverty rates and also RSE, like this table that you can see in the slide here. Next, please. So the second step is to prepare the auxiliary variables that we will use to predict poverty rates or unemployment rates. To do this, we need to prepare some data set that can be used as auxiliary variables. First, we need to list the auxiliary variables that have correlation with or affects the poverty or unemployment rate. To get the list of the candidate of auxiliary variables, we can conduct like a literature study to obtain what factors that influence poverty or what factors that influence unemployment rates. Next slide, please. Now, this one, I mean, this the explanation I have already said before. Like we need to list the auxiliary variables that have correlation with the poverty or unemployment rate, or we also can list the auxiliary variables that affects the poverty or unemployment rates. To get this list, we can conduct some literature study to obtain what factors or what variables that influence poverty or unemployment rates from journal or from papers that we have read. Next slide. Yeah, this is the example of what we have done. So after we conduct study literature, we write down the candidate of the auxiliary variables based on the finding of the journal or the paper that we have read. So you can write down your study literature like this template. So you just put the title of the journal or the paper that you have read, and then the targeted variable here the targeted variable is the poverty rate, and then the auxiliary variables for the poverty rate. Here we have income per capita, unemployment rate, and for the second journal we have clean water, sanitation, distance to region, distance of the region to city center, and for the third journal we have proportion of agricultural families. We have variables regarding distance to junior high school, distance to vocational high school, distance to academy or university, number of mini market, and etc. 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 So we can get several candidates for the auxiliary variables based on journal or based on paper that we have read. So we have read. So we need to do some literature study in order to get the candidate auxiliary variable for small area estimation to predict poverty or to predict unemployment rate. Next slide, please. So after that, what we need to do is we need to adjust the auxiliary variables that is found in the literature study that with the data that is available in our country. Like the previous slide, we have tables that contain several auxiliary variables that may be used to predict poverty, and then we need to adjust those auxiliary variable that we found in the literature study with the data that is available in your country. Please note that the data set for auxiliary variables should be taken from administrative data or census data or registration data or other data sets that do not contain sampling error. For example, for instance, in Indonesia, we have the population census, and we also have village potential registration. In Indonesia, we call it PODES, that basically is a registration and census for all population. So it does not contain sampling error. Please note that one, that you should prepare the auxiliary variables from the data set that do not contain sampling error in order to predict poverty or in order to predict unemployment rate. After that, the data set for the auxiliary variables need to be prepared at the level that corresponds to the targeted variables. So if your targeted variable is at the subdistrict level, so if you want to estimate poverty at the subdistrict level, then your auxiliary variable are also must at the subdistrict level. So basically, we need to prepare the auxiliary variable that correspond to our targeted variable at the same level. So we need to prepare them at the level that become our concern in this study. Next slide, please. So this is the examples of the auxiliary variable at the subdistrict level that we generate from village potential registration data to predict poverty rates at the subdistrict level. Basically, we just do aggregation from the village level because the data, the potential village registration is in the village level. So we need to aggregate the data at to the subdistrict level. So we can see here we have ID catch. ID catch means ID for subdistrict level. We also have variable for slum area, distance to elementary school, distance to junior high school, and etc. etc. And these auxiliary variables are based on the study literature that we have done before, as I previously show you. So basically, we need to prepare the auxiliary variable based on the literature study, and we need to adjust the auxiliary variables from the literature study, from the paper, from the journal that we have read. We need to adjust with the availability of the data that we have in our country that we can use as approximately, or we can use to as a auxiliary variable from the survey, from the survey that available in our country, and then we need to aggregate the data at the level that corresponds to the targeted variable that become the concern of our study. I think that's all from me. Is there any question regarding the preparation of the data? I hope we here have the same understanding about how to prepare the data, in what level we need to prepare the data, and what auxiliary variables that we need to prepare based on the paper, based on the journal, or based on the literature study that we have done, so we can prepare it well, so we can do the small area estimation well also, and the material will be given in next week and also the next 2 weeks, I think, for the small area estimation. Thank you. Is there any question or is there anything that is not clear enough? You can ask a question. Thank you.
Thank you, Miss Dia, for the complete briefing on how to prepare the data, including to select the variables. May I again ask and invite participants, especially for those who already in the previous session mentioned that they currently trying to prepare the data set for the hands-on exercises. Please, do you already clear on how you will prepare your data, including the selection of the variables? Yesterday, we hear from Myanmar that they're currently trying to get approval from their DG to use the poverty data for the hands-on exercise. Do you is it clear enough, or do you have any question on the variables that you should select or use for the small area estimation for the poverty data?
For
Please.
the
Yes, please.
explanation.
Miss
Yeah.
Nyong Tai, your voice is not clear
Yeah.
enough.
Just now we understand we have to ask. Yes, we clear today explanation for preparation data. But just now we understand, so we have to ask property data and RSE.
Yes.
Yes. Yeah.
Yes.
Thank you so much.
Yeah, so you can contact the division that is in charge of for the survey to produce the poverty rates, to provide you with the direct estimate and RSE for the level that you are concerned in this study. Let's say for the municipality level or sub-district level or village level, as long as it's a small area, you can ask them to provide you with direct estimate and also RSE. But if you're confident enough to generate the direct estimate or the RSE, because you understand the sampling design, you can generate it by yourself, like previously delivered by our colleagues from PSA about how to generate a direct estimate. But if you don't confident enough because you don't familiar with the sampling design or the weight or etc., you can just ask them to provide you with the direct estimate and also RSE for poverty or for unemployment rate at the small level that become your concern in this study.
In Myanmar, in our case, we have maybe we cannot get district level, so how it's enough for that? Maybe state and region level is sure, not sure for district level.
So you don't have data for district level, if I'm not mistaken.
So I also not sure. So just now I know poverty data that they already calculated and reported state and region level. But I request to district level. So if I have state and region level, is enough for SAE.
Oh, so you should provide it. I mean, like the division. You should ask the division, that division, to provide
Yes.
you with the estimation at the small level that become your concern. Let's say you want to estimate in the district level. So from the survey, you need to generate the direct estimate and the RSE for the district level. Just ask them to provide you with the direct estimate and the RSE. I mean, like, you can ask them about the data, and if they can provide you with the direct estimate and also RSE for, let's say, district level for all Myanmar area, something like that.
Yes, thank you.
Thank you.
Thank you.
And don't forget to also, prepare the auxiliary variables to predict the poverty or unemployment rate. You can read journal, you can read paper, factors that affect poverty, factors that affect unemployment rate, and you just can search in your country the variables that can predict poverty and can predict unemployment rate, like what we have done. We read some journal and we found that slum area is affecting the poverty, and the distance to high school, distance to university, distance to market affects the poverty, affects the unemployment rate. And then we try to get that variable from the data source that available in our country. In the case of Indonesia, we can get the variables regarding distance to junior high school, distance to high school, distance to university from the potential village potential registration. Or maybe you can use other data set that you have from population census, let's say, or other data source that don't have sampling error for the auxiliary variable.
Yes, thank you.
Yeah. Is it clear enough?
May I, Mbak Diar?
Okay.
Yeah.
Please, Mbak.
Yeah, if the worst case happen, AMS cannot obtain the data until sub-district level, maybe only regional level or district level. For example, only province level that available. Will SIA method still work for that level of data? Can we still use it for exercise?
Okay, thank you for the question. Basically, small area estimation is used if we don't have enough sample at that level. I mean, if your country can only publish at the national level of the poverty, and then you need to estimate the poverty level in the region, in the province, at the province level, let's say, you can still use that data in the province level. It can still be used for estimation. However, if we already have estimation for the province level, and it's reliable enough because the RSE is already lower, and the survey design, the survey is already designed for the province level. So we just need to generate the direct estimate of the estimation at the province level. So basically, small area estimation is used if we don't have enough sample to do direct estimate at that level. If we have enough sample to estimate at the regional level, at the province level, so just go with the direct estimate instead of small area estimation. However, if we don't have adequate sample for the province level, then we can employ small area estimation. Is it clear enough, Mbak Hani? So if you only have province level data, it's fine. We can still do that for small area estimation, but with the note that we cannot have a reliable estimate if we do a direct estimate for that level. So we need to do a small area estimation. If we have reliable enough indicators for the province level using direct estimate, so we just use the direct estimate instead of small area estimation.
Thank you, Adia.
Yeah, you're welcome. Is there anything else for the data preparation? So I hope you have already get the point of the data preparation. So basically we just need to prepare two things: the direct estimate of the targeted variable, and along with the RSE, and also we need to prepare the auxiliary variables to predict the targeted variables.
May we check also with other countries, please? How about Cambodia, Lao PDR, Vietnam, Malaysia? Are you clear enough already on how to prepare your data, including the auxiliary variables? Okay, LSB is clear enough. And hopefully for LSB, you already last time in the first session you mentioned that you have some data prepared already, including the variables. So hopefully it's already set enough and ready to be used for the hands-on exercise, including the RSA as mentioned by Ms. Diaria. How about other, please? Vietnam, may we hear also from Vietnam and Cambodia? And Malaysia. If you have any issues with the data preparation. No respond. Okay, since no response, hopefully other countries already clear enough. And then later, okay, thank you Cambodia for confirming that you already clear enough on the data preparation. May we also know Cambodia would like to use the data which related to poverty or on employment for the exercise? Okay, maybe Cambodia, since no response, you can provide later on the information. So I think that's all for our session today. Thank you so much to Ms. Dris from PSA and Ms. Dia from BPS-Statistics Indonesia for all the supports provided to us in the whole series of the training that already conducted. I think we already have 3 weeks, and then we have 2 sessions left, I think, 2 or 3. Let me check with Hanik. We will have another 3.
It's topic 4, and the last topic on topic 5 is hands-on exercise.
Okay, so we will have another 2. But I think for next week, we have a different schedule. We will have on Monday and Tuesday. Let me check with my calendar. Yes, it will. No, Hanik, why in my notes we will have another 3?
Yes, sorry.
Yes, we still have 3 weeks
3 weeks, right?
to
Yeah,
go.
because
Yes.
because the topic 3 we divided into 2.
Two,
Sorry.
yes.
Yeah. For the next week, we have exercise with
Philippines,
Tata, yeah,
yeah.
from
So
Philippines,
Philippines
and
will. So we already done with 3, and then we will have another 3 weeks of training. Next week we will still have a same schedule on Tuesday and Wednesday, 9 a.m. in the morning. So I think if no more question or issues that will be from participants, that's all for today. And see you again next week on Tuesday. Hanik will send email for a reminder. Thank you so much, everyone, and have a nice day ahead. Bye-bye.
Thank you so
Thank you
much.
everyone. Bye.